Hi there, I'm Olaf Götz from Lenze, and in the next 20 minutes, I'm going to show you how to create a system solution for an industrial machine. In addition, with that, I give you an overview about our planning software, Easy System Designer. The Easy System Designer is Lenze's web-based planning tool for the efficient planning of machine solutions consisting of automation components, drive components, and even PLC software. The tool helps you to structure your machine by modularization on different levels, to select the right products and to configure them, to check the solution, to report it, and to transfer information to further engineering tools. In my example, I want to create a drive and automation solution for a sorter machine. Its task is to sort incoming chocolate pralines into a packaging box. Let's go into the web browser. I enter the address systemdesigner.lenze.com. Then I have to log in with my credentials. I'm now on the home screen where I see all projects that I have created or someone else shared with me. By clicking on the button Add New Project, a new one will be created. I enter important project information like the project name and the general description. Additionally, I enter a name for the machine. Here I'm able to upload a picture of the machine from my local computer. The first important step in creating a machine solution is the machine modularization. That means the structure of the machine has to be defined. It starts with machine modules, considers submodules, and goes down to drive axis. This structure can be defined on different levels, very flexible based on the needs of your machine. I start with the infeed machine module. Therefore, I add a machine module. In this dialog, I name it infeed. And I assign a picture to it. By clicking on the infeed tile, I get into this machine module. Here I want to define the needed drive axis. Same procedure as before. I add a new submodule. The type is a drive axis. Now I describe the conveying process in the process requirements. One important information for the later system check is the requirement of the application to the controller that we will select later. The system designer offers you experience values of standard applications for this check task. In this case, I use basic motion because the conveyor is a standard motion task. The prepared PLC software function of the conveyor can be selected from the FAST technology library. We can see next step is the selection of the inverter. For this conveyor application, the standard frequency inverter of the i500 series is the right one. In the product catalog, I filter the rated power. It should be between 3 and 4 kilowatts. I select the 3 kilowatt device. It is now placed into my drive axis. Additional information are directly available. These are the product information. And here I can view the product and generate CID data. For sure, the drive axis needs a geared motor, which I can add in the overview of the drive axis. In the product catalog, I use the filters to find the right product. Power of 3 kilowatts, output speed of 100 till 105 RPM, bevel gearbox G500B, motor series M550P, that is an IE3 standard AC motor. The second one is a good solution. After I have placed it into my solution, I can do the configuration of the options now or later. In the product configuration, not yet defined options like mounting position, brakes, or feedback systems can be selected. The autocomplete button sets all options to default values. But please check them if they really meet your requirements. We now have defined a drive axis for our in-field machine module. The button left besides the breadcrumb navigation opens the topology picture that shows the structure of the actual solution. This topology picture is interactive and can be used to navigate through the machine. Let's define the next machine module, the sorter. On the top level of the system architecture, I add a new machine module. I call it sorter. Inside of this machine module, I add a new submodule. I know in my machine it should be a delta kinematic that consists of 4 degrees of freedom. That means 4 drive axes. The system designer offers me for such kinematics an assistant function. I have to select assembly group and can activate the robotic assistant then. In this assistant, I select my kinematic and the degrees of freedom. When we now take a look into our topology picture, we see that the assistant has created the needed structure for the sorter. In the process requirements, I select the typical cycle times for this application. The PLC kinematic component of the fast library is selected automatically. Here we also see the needed application credit. There are different fast technology modules possible. I select the standard pick and place module. You can imagine that now the same tasks have to be done as before. That means selecting the inverters, motors, and so on. But a highlight that I will show you is the selection of the double-axis inverter i700. The double-axis inverter has two motor outputs. I select a 2.2 kilowatt device. The system designer asks me which motor output I want to use. In this case, A is a good selection. Via the machine tree that I can open with the hamburger button, I navigate to axis 2 of our delta picker, because this axis I want to assign to the free available motor output. In the inverter selection, I use the button Free Double Axis Motor Output. The dialog shows me all free available motor outputs of used i700 double axis inverter. I have now prepared the complete solution for the picker module. We see it here in our topology picture. Our last machine module for the sorter machine is the outfeed module. Technically, the outfeed is the same as the infeed. Because of this reason, I need just to copy the existing infeed module and call it outfeed. A look on the topology picture shows the actual solution for all machine modules. We see the different drive axes and the PLC software functions that we have assigned to the different modules. In the system architecture level, I can select automation components. First, I select a visualization component. In the category IPC and monitor, I find a V800 industrial PC. In the next step, I can organize the I/O system for my machine solution. First, I add the bus coupler module for the EtherCAT network. Then I can select for this bus coupler different I/O modules. For example, modules with digital inputs and digital outputs. With the copy function, I can easily extend the I/O modules. The system designer automatically checks if a power supply is needed and proposes where to place it. A detailed look at the bus coupler shows all useful evaluation results like power supply, EtherCAT communication, available signals, and physical dimensions. Another highlight is the support to select the right controller for the machine. In the Controller tab, I can add the controller. Here we see direct which controller fits the requirement from the complete machine structure. Therefore, the selected inverters, the selected PLC software function, and the applications themselves are taken into account. For our machine, the controller C550 is the right one. I can take a detailed look on the performance data like CPU time, EtherCAT, and the application feasibility. For the selected fast PLC software functions, a SD card is necessary to cover the needed application credit. The total application credit is shown here directly. In the selection dialog of the SD card, I can see that level 300 is the next one that I can select. If I want to use later further fast technology modules, I should left some reserved for the application credit and take a bigger SD card. Quickly, I configure open options of the controller. For my example, these are enough products that I want to consider. For sure, there can be more products selected. For example, safety controller, drive and automation accessories, and so on. Let's go into the project dashboard where I get an overview about my project and machine solution. The topology picture is placed here too. As you remember, it is interactive, so you can use it to navigate to components where you want to go. An important information area is the status. Here are warnings, hints, or open tasks displayed. Further on, I can use additional features from here. It is possible to share a project with other system designer users so that they can take a look into the project or even edit and support to create a solution. It is just necessary to enter the email address of the user and then to assign him the permissions like read or write. If I want to generate a solution report, I click on the button System Report. In the system report, all useful information about the project, the machine, and the solution are documented. So it is possible to report the solution to further stakeholders. I click on the button Transfer to EPF Basket. With this action, it is possible to check commercial aspects. The complete bill of material will be transferred to the basket of the Easy Product Finder. Another tab will be opened in the browser. There you can do a request for quotation, or if you have a login, you can generate the prices and check the availability of the products. We are ready. Finally, I want to give you a short summary. The Easy System Designer is our web-based tool to plan complete automation system solution. Your benefits are save time with quick and easy system design and reuse of solutions. Early proposals provide safety to make the right decisions. Increase quality and efficiency in the planning, both for standard tasks and special machines, by the help of integrated expert knowledge. Secure consistency in the engineering process by generating documented and transferable results. Improved collaboration in machine development by using a common planning basis for all stakeholders. Thanks for watching this video. Now it is on you. Try it yourself.